Right, in this equation, what they have given us is basically a profit equation for this Canon instruments, and they're producing X units of this special camera. Okay, so X in this equation represents the number of units of the number of cameras, basically, and then what it's going to find for us this time is profit. So real quick, we've been dealing with two types of P's. A capital P stands for profit, and if we've done everything in the couple examples prior to this, it's actually lowercase p. Lowercase p usually stands for price, and then uppercase p is what they're holding out for profit, okay? So now what we're going to do is we're going to take this equation, and we want to know is specifically how many cameras, so what's the X value, does this Canon company need to do in order to produce per month in order to maximize its profits. So what's going to give us the maximum? Well, obviously, this is a quadratic equation, so we're looking for that high point. What we're really looking for, we want to find the vertex. Okay, so that's the whole goal, is to find the vertex here. Okay, so we have a formula for it. The vertex, the X value there is just negative b over 2a. So it's negative b, which is 240, over 2 times a, which is negative 0.04. And just kind of using our calculators to help us out with this. We'll get an X value, it looks like, of 3,000. Okay, and if I plug that back in and said, okay, what's my profit at 3,000? Negative 0.04 times 3,000 squared plus 240 times 3,000, and then minus 10,000. What's going to come out here is a profit of $350,000. Okay, so my vertex technically is 3,000, comma, 350,000. And so what we've just found, if I want to interpret what I've just found, is that if I sell, or this Canon company sells 3,000 of those specifically, gosh, what were this? Number 37. So the M1 cameras, if it sells 3,000 M1 cameras, it's getting its maximum profit whatsoever it can ever get. And for that company to plan on it, if it wants to know, okay, what will this profit be? It's $350,000 they'll make in profit. So is it to its interest to sell 2,999 cameras? Not so much. Even if it wants to sell 3,001 cameras, no, not so much. It's right at 3,000 cameras. It's going to get its maximum profit whatsoever. Because anything less than that, then it's probably, it's not bringing in enough money to actually go over the cost. And anything more than 3,000, maybe the costs are going to be too much. Maybe they can't get quite of a deal, or items like that. So it's definitely something to keep in mind. But anytime you're asked to maximize or minimize, your whole goal is to find the vertex. All right, and then just to wrap up this lesson, let's just go to number 46 in the book, and let's look at those problems real quick to finish this up. With this problem, it's kind of something similar we just did just 2 examples ago. We're given 2 equations. One's a demand equation, and one's a supply equation. So the demand one is this first one, and then the supply one is this second one. And X is going to be just the units in thousands like normal, and P is going to be the price in dollars. And again, see how it's lowercase p, so it's definitely talking for a price as opposed to a profit. And what they want us to do is find the equilibrium. So what we're going to do, obviously, is go demand, figure out when does demand equal the supply, or supply equals demand, same thing. So I'm going to take that 144 minus x squared and set it equal to 48 plus 1/2 x squared. And right here, if you first of all, just before you get any further into this, for moving some stuff around, we could clear the fractions. It's up to you, whatever you want to do. I might, just because I can. There's only one fraction, so let's multiply everything through by 2. So 288 minus 2x squared is equal to 96 plus x squared. All right, let's move the x squareds to one side. Let's move the constants over to the other. Mainly because if I don't have an x term, I just have constants in the x squareds, then I can do this. I don't have to worry about setting it equal to 0 unless I really, really want to. Okay, so 288 minus 96 will be 192. And 1x squared plus 2x squared is 3x squared. So if I divide by 3, oops, A little sloppy looking 3 down there. Let's clean that up. Then I will get x squared to be 64, and we're going to take a square root, plus or minus. So x is equal to 8, and x is equal to negative 8. And again, since x represents either the quantity demanded or the quantity supplied, we can't really have a negative of them. So equilibrium. Equilibrium quantity is not just 8. Just remember it's in thousands, so it's going to be 8,000. And then to get the equilibrium price, all we're going to do is go back to either one of those two equations and plug it in. So we can say P is equal to, I don't know, how about 144 minus 8 squared? We'll go with the very first one. We'll go with the demand equation. So 144 minus 8 squared, which is 36, will give us a price of $108. So right there, whenever, as a business person, if I price my item at 108, again, just like those cameras, then I need to plan on having 8,000 items on the shelf, because 8,000 people are going to walk by and go, hey, $108, that sounds good, I'm going to buy that. All right. So this wraps up this lesson, where we focused more on linear equations and quadratic equations, both finding the equilibrium point, specifically with quadratics, or the break-even point with like linear equations. All right, and after this, we're going to jump into Chapter 3.